Welcome everyone. Good morning, good afternoon, and good evening. I am Vikas Choudhary, a staff engineer at Seagate. I have around 17 years of IT experience, mostly in networking and storage domain. I prefer to work with Python. Python is my primary choice of language. At present, I am working with uh, automation and tool development team with Cortex. Today's presentation is about the tool we are working, and it is continuously in development to check the IO path stability. So IO path stability means longevity, stress, scalability, and reliability. All that is covered by the tool. Now let's see the agenda. So we will see today why we need Core IO, some overview about it. There are some focus area and the workload, samples and execution process. There are some features. We added current and extended features, some fact sheet about tool, future roadmap, and question answer. So first thing is why Core IO? So there will be question like we have so many open source or third-party tools which does IO operations. So why we need to do develop or have this another tool? So there are reasons behind that. Uh, when we were exploring to our requirement at least, so we saw like there are tools, but there are limitations. For example, a single object size only can be exercised at a time. Only one type of operation can be exercised at a time. And there were sequence patterns. When we run multiple sessions or multiple clients, then only tools are working on the same object size, given any object size, or any given operation, like only bucket operation, only object operation at a time. So these are some specific limitations. Other limitations we see, like we cannot use different features of different tools together. We have to use different set of tools. They were very specific. But we customize this tool to use capabilities of different tools inherently, and we can add on as and when needed or required. So we are open for extension. So this is a specific feature of this tool, or this is a specific IO tool. So as of now, we are covering the S3 protocol or S3 specific operations, but in future we are open to add anything like any other IO protocols, for example, NFS or anything. So if you see here, so what is the specific with that tool actually? So there are different workloads. Workload, I mean to say there are different operations. For example, object operations, bucket operation, multi-part operations. So we can simulate the underlying scenarios or underlying test cases simultaneously, and even those scenarios will run simultaneously. So there will be parallelism over parallelism. And at some time, due to continuous stress, we will make sure like our system will give up. There will be issue. So it makes sure like we will find the issue. So we can run this tool over VM or hardware. We are discovering and developing the fault injection capabilities using chaos engineering tools like Chaos Monkey, Cube Monkey. So those can be added. We have different capability to notify the user with email. So when we start the tool for execution, we get the email after some intervals, defined intervals, or that is customizable even half an hour or in every 1 hour, we can get the email of the status with the log files attached. And whenever test stops due to any failure or abort or pass, we get the email. Also, there is a Jira integration where we update the status of the test cases or workload execution. So these are the basic features CoreIO has, and we wanted to overcome those limitations. And we were able to achieve that. This is the open source repository. So anybody can go and see the code, and we welcome anyone to even contribute. Now let's continue. Now talk about some overview and design, what all we have. So like I mentioned, we have different configuration files. We say them as workload configuration. because there are key value pairs, there are parameters. I will show the example later. So those key value parameter, any user can update, give, and customize. And user can create a number of workloads. There is no limitations. You just need to change the configuration. You just need to add different parameter, different values for those parameters, and workloads are ready for execution. For example, there is a bucket operation, there are object operation, multi-part operation. So you can have a n number of workloads for specific and each of the operation. You can see like there are green marks and one of the cross marks. So it's like if you want to run two workloads, three workloads, or n number of workloads, we can select those and we can. There is a CORIO framework. So this is a engine of this tool, which includes driver. There are system monitoring capability, Jira integration is there. So driver takes workloads and some input parameters given by the user, some are default, and execute those workloads. As a result, we have a log files, we have a log bundles, there is a continuous health check of the system. So that is a continuous actually. So the philosophy was behind this tool was like it should never be stopped. It should stop only when there is a issue with the system. So this there is a separate CoreIO library we are developing. So in this library, mostly we are using Boto3, third-party Python library. So we are developing IO module using that. We have a client-side data integrity. We make sure like whatever object we upload, same should be downloaded. And fault injection capabilities, we are working on that. But as of now, as a part of degrading pods and those scenarios we are exercising. And also we are open to add chaos tools and corruption tools. Yeah, so you can see like this framework is both IO intensive and data intensive. Distributed environment, we are open for execute on a number of nodes. Cluster size can be anything from 3 nodes to, so we have tested on 9 node and 15 node. So it is open for any n node of configuration. It is pluggable. Like I mentioned, different module can be added anytime. Tools capability can be added anytime. If you find actually there is some other tool which has some capability we are lagging, so we can add that capability. We also record everything, whatever is going in on behind. So we record everything. So we get the test result. And if there are issue, we are able to debug based on those log bundles. So let's talk about focus areas. According to the philosophy, we wanted to have this tool as a plug and play application. The primary focus was scalability and stress. Also, data integrity and high availability test is a major part we wanted to cover. And rest thing is tracking. So we don't have these things in any other available tools. So we have integrated, we have this facility, we have focus area. So like what is plug and play? So we have workload templates ready-made. So user can update those templates, add those templates, and execute a number of templates. So by means of test execution or workload execution, we are open, anybody can add and run. So any use test matrix. As of now, we exercise up to 12 scenario in a single operation, but user can have 13 or any time based on the time it can run for any time. So about scalability and stress, we have a large number of client session simulation. I mean to say, as per the capability of the client machine where we are executing this tool or the as per capability of the cluster. So whatever the maximum support, it can exercise. So we exercise in hundreds client session simulation. And object size also getting increased with time. And there are number of objects also getting increased. So that is scalability and stress. About data integrity, I already mentioned. We check the DI for the objects we upload and download. Also, we are working to have end-to-end DI validation as a separate feature. We will add with this tool. Also, with fault injection, KS Punky and different tools, we will be able to check system behavior. And about real-time tracking, we have email notification continuous. I will show the template of email notification later. We have added Jira, so we can have real-time tracking there. Execution of the test case. This snap also I will show you. And also we have made it executed on CI/CD with the help of Jenkins. We can trigger the test cases anytime. There are parameter user can fill in and execute. So there you can stop me for any short questions, or we can take it end if needed. So this is workload samples. So for example, this is a file, workload file. There are 3 test cases, but I will say there might be a number of test cases. So how the design of the test case? So there is a test ID, object size. There is a minimum runtime, sessions per node, tool, and operation. So let's see one by one. Test ID. So this is very important key for any test scenario. You will see there are different test ID for different test scenario there. So this test ID is used to interaction with Jira. So whatever the test case or test ID defined in Jira, same test ID will update there. The execution status will update. So that is integrated in that way. And also the when logs will be generated. So separate log will generated for separate executions. So there will be a prefix of this test ID for the specific test case. So there is a dual purpose, and internally we are handling that logic. About object size. So we are giving range from start to end. So that is also customizable. You can give any value at start and any value at end. And whenever we'll run this test case, any random value will be taken from this range, and we will make sure whatever number of sessions will run, those will have different object size to exercise. So that was the capability other tool don't have. This tool have that capability. Minimum runtime, I mentioned here 2 hours. The meaning of this 2 hours is like whenever this scenario will finish a timeline of 2 hours, we will mark it as a pass, or we'll consider it a pass, even though it will run in background continuously. Session per node 1. So here also you can see this parameter is getting changed actually. There is 2, there is a 3. So what is the meaning of this? So this is used to define the number of sessions to run on a specific node. So suppose, for example, you have a 5-node cluster, and user need to input like he is running the scenario or workloads on 5 nodes. Then we need to make sure like on every node, 1 session at least should run. So we'll send total 5 sessions, 5 into 1 to the endpoint. Same way, if there are sessions per node 2, and there is a 5-node cluster, then we'll make sure like there are 10 sessions, and every node should run 2 sessions. That way it will be add on actually. Sessions will be add on. There will be once 5, then it will be 10, then it will be 15. So total it will be kind of 25 when test will reach here. Tool we mentioned S3 API. So S3 API mean like we are using Boto 3 API operations. We are doing everything, every execution using API. So this is the also customized parameter. If there is a support from any external tools or add-on tools like S3 Bench or anything, and if this bucket operation scenario can be exercised with that, we can mention that as well. So that is open for the user. That is the very basic or best I will say feature of this tool. And operation I mentioned bucket. So for bucket operation, we will mention bucket. For object operation, we will mention object. So this is the identifier for that. So same way, if you will go, you can change actually, we have changed the parameter for minimum runtime, sessions per node. Even this can be changed. So all this based on user, but this should be predefined, this test IDs. Now let's see the samples for other areas. Like I show you bucket. Let's see for other areas. So these are real YAML files. You can see bucket operations, random size object operations, multi-part operations, and copy object operations. So there are test cases. Mostly parameter will be same, like test ID is everywhere. Object size range is everywhere. For multi-part, there is different. So we can have add-on parameters. So those are different. In operation, you can observe like for bucket operation, we have a bucket. For object, we mention object. For multipart, we mention multipart. For copy object, we mention copy object. And why I am showing to you? Because we can run all these 4 workloads together at a time. And one of the first test from every workload will start. And once it will complete 2 hours or defined time, it is 2 hours for every test one. Then test 2 will start from this workload. And test 1 also will continue. So in this way, we will keep increasing the number of sessions, number of threads or client, we can say, and also the object size. So by the time there are 12 test cases, it can be n test cases. So by the time there will be some time, someday like system will give up. So these are just an example of IO patterns we are executing. We have just defined internally. This is first pattern is like bucket and object operation, CRUD operation, where user give the input and number of samples to be run on particular object size. So we run it continuously in loop. Second is simple CRUD operations with incremental sessions, like I mentioned before. Third is kind of write 100% of user data capacity and read in iterations. These are kind of scenario. Type 4 is kind of write 30% of user capacity, read entire data and delete something. So we can vary these percentages of write, read and delete operations. So we can have any type n where we can have mix of read, write, update, delete operations. And that is our tool support. Now we can create any type of IO or IO patterns. So these are supported object operations. So we support bucket, object, mostly everything from these operations, multi-part operations, multi-part part copy and copy object operation. So we'll keep adding any support or any operation in future. So now there will be query about the help and command line options, what user need to give. So I will show you first this command line, and there is a then UI I will show you. So both way we can run with command line and as well as with Jenkins UI. So this is the test input. So this test input is the path. So first parameter is test input. This is path for the directory which contain YAML files. Like I mentioned, object operations, bucket operations. So there are different workload files. So if we'll mention multiple files in this path, so multiple execution will happen. If you mention one file, one workload execution will happen. This is option of verbose if you want to have a debug log information in our log files. Otherwise, default is info. Also, there is a capability we can use this S3 operation either with HTTP or HTTPS, both. So if user will give option like use SSL, operation will happen with HTTPS. Otherwise, it will happen with HTTP only. There is a one more feature we added, seed. So if we will execute with seed, then we can again regenerate the same scenario with the help of seed. So this is used to find the issues and bug. If there are issues and we want to again verify, so we can verify with that seed. So that is the additional capability we added. The secret key, access key, and endpoint are compulsory and need to be given by the user. Number of nodes is a cluster size. Like I mentioned, 3, 5, 9 or any. There are log bundles and health check. This extended feature we added. Health check, there will be a separate session of separate thread which will continuously check the health of the system under test. This test plan is optional, but if you are executing and you want to update with Jira, we need to give this test plan. Also, we can run degrade mode. So meaning of degrade mode is here to downgrade any given pod, data pod or any kind of pod. We have added retry operation also. So if there are any failure and we want to forcefully retry, so we can do that if switch is enabled. And we have added sequential run also. So I will explain what sequential run. So like I mentioned, we have different workloads and we are executing them in parallel. So workload will execute in parallel. Also test cases are executes in parallel. They don't stop. But in sequential run, Test 1 will stop and then test 2 will start. So that is the additional facility if user want to exercise. Now let's see operation with CORIO pipeline UI operation. So here with CI/CD integration, user need to give client node, FQDN, or then endpoint. User need to provide access key and secret key for S3 operations. Then user need to give the size of the cluster, number of nodes. So by default it is 1. User need to change it 3, 5 or any value. Then user need to select what operation he want to exercise, what kind of workload he want to exercise, whether bucket operations or object operations or any 1, 2 or anything. Any combination will work or all, whatever is supported. This is test plan for the Jira update. User need to mention test plan here and the credential. This is the repo. By default is dev branch. And these are optional options. If user want to continuously check the health of the cluster while run the IO, he can check this option. If user want to generate log bundles, he can check that option. And if you want to run sequential run, he can check up the option. Otherwise, everything will be parallel. These are the details of the master node of cluster: host name, username, and password. And these are options are for degraded node if user want to exercise. And these are the alert mail ID. The user can mention any customized email ID there to get notification, and email ID can be separated by comma. Yeah, so everything is clear here. So we talk about options to execute the tool. So there are reporting. So when we start the execution, so there will be a real-time reporting. So this is the real-time snapshot of execution. So we executed bucket operations workload and object operation workload. So you can see here the path of the file. So they are under some IO folder. And you can see the total execution was 10 days. Is 10 days total execution for both operation were running. And you can see the start time, started some defined time. So all will start in queue and they will run. And there will be kind of passing time actually, like this time is passed. And you can see when this test 7 or test 8 is in progress. So it was running for 3 days, but the above test cases were running for more number of days. So first test case was started 10 days before and it is still running. So you can see actually by the time there will be a increased load on the system by means of these sessions, addition of these sessions like 5, 10, 15, 25, there will be addition of these sessions. And same is applicable for this workload as well. So at some point of time, system will fail, or if it is robust, it should continue whatever defined criteria it is. We define for 12 test cases for 1 month duration. So above was for in progress situation. So if there are some failures, so for example, this bucket operation at this test number 9 is failed because of some reason or any reason, then what will happen? The test case which is running, it will be aborted. The test cases which are already run, we will mark it pass, and rest of the test cases will not be triggered. We will collect the log bundles. Notification will be sent by email to the concerned users. And we are open for filing defect and for any further investigation with the system. So like I mentioned, this is the view of the Jira, where we see like some number of test cases are green, means those are already passed. Some tests, this test case red mark is failed from bucket operation. That's why test case from object operations marked as dark is aborted, and rest test cases are not started. So this is the status at the Jira side. This is email notification. When we start the test cases or CORIO execution, we will every time interval we will see this notification in progress, and it will have some attachment logs for the purpose of the user. This is for if failed, so we marked with red this status. If something is aborted manually or for any reason, it will marked as a yellow, and pass will mark as a green. If something, everything will happen successfully. So this is the, and we are working to enhance this as well. But whatever information is required, is cluster health is there, execution duration you can see is here, system capacity we are reporting here, another information in this attached file, summary report like I mentioned you, status, polish status, system logs, so those will be there. Yeah, so let's talk about current features. So we have a resource utilization and collection feature as well. Like when we are executing, so CPU uses and memory uses with client and server on every node, we are recording that. Every time we are publishing that, and whenever we are having issue, so we are collecting that information as well, so that can be useful at what time, what are the uses of memory and CPU. And also we are collecting the logs, general CTL and system log DMSs. And we are further working to enhance this feature to incorporate some kind of AI capability. I already mentioned Jira integration is there. There is a CI/CD execution we support. We support S3 operations with HTTP and HTTPS both. Also, like I mentioned, seed. So our scenario are reproducible, same workload for same sequence. And also we can retry for S3 operations. If user want to retry for any failure, so you can exercise that operation as well. With parallel execution, we have sequential execution support. But again, this is a mix of parallel and sequential. Sequential execution from the same workload, test one after test two, then test one will stop. But in parallel, nothing will stop. So that is the only difference. There will be notification for in progress or about or failure or completion status. There will be real-time logging. We have a console logging or separate logging for separate test thread or session. So suppose we are running test one, test two, test three from one workload, test one, test two, test three from other workload. So there will be 6 separate logging or log files for those test cases. So we update test execution status as well. I mentioned already. And also sessions are, we make sure like IO sessions should be distributed over cluster. So based on the cluster size, we calculate internally that formula and we generate those sessions. Tool is developed using Python 3, a choice of language, open source, and that is open source repository. There are some extended feature is on demand, like health check of the system, log bundle generation. So that depend on the system under test. And we also upload the log bundle to a defined location that can be any NFS server, so that anybody can access, any developer for doing fault analysis reference for any reference. So I want to talk about some CORIO facts. We are executing this tool since 4+ months, both on VM and hardware. There are no such limitations. And we discovered issues related to the system panic or memory leaks in IO path, out of memory errors, race conditions, and we filed those issues. And also is hardware has more capabilities, so we run longevity test for n number of days or more number of days, 2 weeks or 3 weeks, more than that on hardware to compare the status of system and data. So our roadmap. So till now, whatever we have, we discuss. We have some roadmap. We are working on that roadmap. We are planning that. First thing like status collection and resource monitoring. We want to update that feature. We want to introduce some kind of AI capability. Also, we want to have a sustainability of IO operation for long duration. It means from client to server side, everything, whatever we are doing, we want to make sure like everything is per process or everything is correct. So that check we will update over the whatever we are doing as of now. Or also we are adding Chaos Monkey and Cube Monkey to test error injection feature for data reliability over prolonged run. Also, we are open for additional IO tools. S3 bench, I mentioned, there are other IO tools. So a wrapper can be written over those IO tools and their specific features can be exercised with CORIO. Data integrity feature we want to enhance for end-to-end integrity from client to server side as well. Also, we are adding different scenario for degrade mode support, where you want to degrade pods or nodes. Also, we are generating log bundle as of now, but we want to add a feature of doing automated analysis with homegrown tools, separate tools, so that at initial level, we can find the problems and update accordingly. Also, we are open for other protocols I mentioned before, like NFS, SMB, or block level protocols. So this tool can be added for that. It is not for just S3, but as and when whatever will come, that can be added. This is the IO stability tool. So these are all references. Anybody is free to go and open and see the README documents. We have design documents. We have workload configurations. And for any queries and anything, you can come back to us. Yeah, so this is end of the session.
Thank you so much. I want to remind you all that these sessions happen every month. Right now, they're happening on the second Tuesday of the month. You can find out more by joining our newsletter. If you would like to check out Cortex, you can at the cortex.link/GitHub. And we love to have people come to these sessions and give talks. So if you have a talk that you would like to give, please let me know. I'd be happy to have you join us. And I guess I'll see you next month. Thank you.
Thank you, everyone.
Thank you, Vikas. Thank you, Rachel.